Good morning guys and welcome back. Now in this video we will start solving a problem that needs to use find. So remember, find is used if I need to check if a certain condition is valid or if a certain statement is true, and find will give me as output the indices of the elements that have a true answer. So guys, basically this example is based on projectile. So I know that the height and the speed of a projectile in a function of time t is as the following. So I know the equation of the height, I know the equation of velocity, and let's say I know v0, I know the angle to horizontal, and I know the acceleration or gravity, and I know that the projectile will strike the ground when this height is equal to 0, and this will give me the time to hit. Alright, so I know the time t is equal to 0 is the initial time until t hit where this projectile is hitting or striking the ground. So if I suppose that a is equal to 40, v0 is 20, and the gravity is 9.80 meter per second squared, I need to find, so the question is to find the times when the height is not less than 6 meters and the speed is not greater than 16 meters per second. So I need to find the boundaries of time, so let's say between this time t1 and this time t2, where the velocity is less than 16 and the height is greater than 6. So guys, basically, of course, I should have two different relational operators here, because I know that if the height is greater than, then the velocity is less than, because they are exchanging the potential energy with the kinetic energy. So I need to find the time where these two conditions are valid, and of course this will be done using find. How to do this? Using a script on Matlab. So let's do it. First of all, I'm going to open Matlab. Okay, clear all my variables in my command window, and then I'm going to open a new script. Alright? So I know, guys, that the script should be started by CLC clear all, and then that the angle is 40 degrees, and I'm going to directly convert this angle from degrees to radians. Okay, so I'm going to convert this angle from degrees to radians by multiplying it by pi over 180. And then V0, you can say small v or big V, V0. So I'm using here small v is 20, and then the gravity is 9.8. And I need to find the time, so I'm going to do this as a command. So h of t is greater or equal to 6, while v is less than or equal to 60. So guys, the first step is to find t hit, because in fact if I need to find the time or the interval of time or the boundaries at which this h and this v satisfy these two conditions, I need to find what is the whole interval of time. So I know, guys, that this whole interval of time starts from 0 till the t hit. So the t hit is when this h is equal to 0. So if you put this is equal to 0, of course the first time will be t is equal to 0, which is not valid here. And the second time will be, of course, v0 sine a over 0.5 gravity. So this is the second time, and I'm going to define the second time as t underscore hat. So t underscore hat will be equal to v0, small v0, because I used v0 in small letter, times sine of a. I'm sure that a is in radians, so I can use directly sine of a. Okay, so it is v0 sine of a over 0.5 times the gravity that I have defined here. So in order to make sure that this t hat is valid, I can run my code here. So I'm gonna call this code here project try. Don't forget, I cannot use the spaces in my script. So this is t-hit. It is 2.6236. You can, before running this code, continue it, and then when you finish it, you can run it. But I advise you guys to do this because in this case, you can locate your error before having a huge code. Now, you'll not have a huge code in this example because it is basically a very simple example. So what I'm going to do now is to define an array going from 0 till t-hat. Now what you can do is, let's say, use the colon operator going from 0 till t-hat. But in this case, don't forget, guys, that t-hat is 2.6. So if you use this, by default, the increment will be 1. And then you will have only like 0, 1, and 2. Now this is not what we're going to do here. Since 2 underscore hit is very small, what you can do is basically use this as an increment, so t underscore hit over 100, until t underscore hit. So this could be the first option. Or what you can say is t is equal to linspace. So since I don't know now the increment, what should be the increment, but I know that I should divide this t-hit into very large number of nodes. So I'm going to say t is equal to linspace. Now Matlab will help you by providing you the order of the inputs. So what you can say is 0 t underscore hit, and to make sure that you have a very large number of nodes, you can use 1000, and even if you don't specify this number of nodes, Matlab will take it as 100, and 100 is also acceptable. Right, so you can say like this: t is equal to linspace 0 till t-hit, and then in this case you will have 100 nodes, but in order to be more accurate, I'm going to use this linspace 0 t underscore hit with 1000 nodes. And then, guys, I need to find this height and this v for each time because I know their equations. So I know that the equation of h is v0t sine a minus 0.5g t squared. So this is what I'm going to do here. Okay, I'm going to say that since t now is an array, so I can also define the array h as what? So guys, don't put h of t. This is not valid because h is not a function that needs inputs. This is h that is an array v0 times t times sine of a minus 0.5 times gravity times t squared, and don't forget that t here is an array. So how to make the square of this t? I should put dot squared. So you can see, guys, that in Matlab, I cannot write a script if I don't have some background on arrays and matrices. And I should use all my background in any chapter, right? And then v is equal to what? sqrt of v0 squared minus 2 times v0 times gravity times g times sine of a plus gravity squared. I don't have to put dot here because gravity is a scalar, but here since I need to make the square of t, dot squared. Alright, so this is how you can write h and t to make sure that they have good answers. I'm going to run this code again. I have an error, so let's see what is this error. So MATLAB is saying that undefined function of variable VO. So I wrote VO instead of V0. So this is at line 12. I can click on line 12, and here you can see that this is my error. So it should be V0. Okay, and then I run it again, and then you can see that T has a size of 1000, H and V will have the same size. So if you take a look on V and H, how? By double-clicking on this V, so you can see, guys, that V is decreasing, all right, until 1000, and then until a certain node number, and then it will be increased again, all right? And then for H, it is increasing until a certain node number, and then it will be decreased again. Of course, should be 0 at 1000. Alright, so this is H is 0 at 1000. So what I'm going to do is to find the time at which H is greater than 6 and V is less than 16. So I'm going to use find. But I have to define the output here. Let's say it is U. U is equal to find H is greater or equal to 6 and V is less than or equal to 16. Now, what do you think will be the output of this U or of this find? The output will be, of course, saved in U. But think about it. What should be this output? It should be a row vector that basically, I don't know what is the size of this U, because it includes only the indices that has H is greater than 6, at the same time V is less than 16. So you can try this by running this code, and then double clicking on U. Then you can see, guys, that these are the indices from 3 to 2 till 6, 7, 9. These are the indices where these two conditions are valid together. So it is from 3 to 2 to 6, 7, 9. Now, am I done? Do you think that so far I answered the question? Let's go back to the question. The question is to find the times when the height is not less than 6 and the speed is not greater than 16. Which means, guys, until now, I found the indices of the elements, but I did not find the time. So how to find the time? Basically, if I know the index, I can find the time at this index. And this is by defining, let's say, T1 is T of U of the first element. So basically, the first element of U is a 3 to 2, as you can see. This is the first index of the valid conditions. So what I'm doing is to find T of this index. So T of 3 to 2 and T2 will be T of the last element of U, which means U end. And this is here the importance of end, because in fact I don't know the size of U. I'm using find. I don't know the length of U. So and will give me the last element of U, and this will be the second time. Which means, guys, if T lies between T1 and T2, then in this case, guys, both conditions on H and V are valid. Conditions are valid. So that's it. This is how you can use the output of find, which is the index, to know the value of this element itself. I know its index, I don't know its value, so I can use find from the index, which is the output of find. I can know what is this value. Thank you.